Good morning, everyone. I was supposed to put this out yesterday, but I ended up hiking and eating supper and having fun. So here's the video the next day. Today we're going to do some more basic ROP gadgets for everyone. And what we're going to do is jump right in, crash the program, and I'll show you where we're going from there. But today we're going to do a jump EAX. Find a jump EAX gadget and use it within the vulnerable binary. So let's just jump right into it. And let me get to my working files here. Okay, so today we'll be working on the same vulnerable binary as we had last time. So the first thing I need to find out the buffer size. So we'll open up GDB, and now we'll disassemble the main function. Let me open this right up. And as you can see here, there's another function here called vulnerable function, which is always good. Only if they always call them vulnerable functions, eh? So we'll disassemble the vulnerable function. And as you can see, here's a stir copy, which is vulnerable to buffer overflow because it doesn't do balance checking and we can overwrite adjacent memory. So what I'm going to do, I'm going to put a breakpoint right at this one, right before it takes our input. And now what I'll do, I'll open a new terminal. And let me do open my Freya up here. And what we're going to do, we're going to get a new block to fuzz this program with. So I just picked 2000. So now I'll just open up the text file where that's saved and close this out. And I'll open up the exploit. I don't know what I got wrote in here now. So let me just get rid of this here and put in our new 2000 string character. Save. And now I'm going to turn that exploit into a payload. So what I can do now, I have my breakpoint set. So I'm going to run this with a payload. Now I'm going to display 132 words from ESP. Whoops, all in capitals. Display 132 words in hex from the ESP, please. And there we go. So if I print where our base pointer is at 798. So here's 79, and this would be 8 right here, counting across 3, 4, 5, 6, 7, 8. And of course, this here would be the return address. And here's our stack pointer up here. And this would be argument 1 and argument 2. So now that we know where everything's laid out, I'm going to hit next instruction. And we will go back to display again. And as you can see, now everything is filled up. If we hit 798, as you can see, the values have changed here. So this has been overwritten. So what I will do is I will continue on this program until it crashes. And as you can see, it's crashed. So now I'm going to come to my EIP and I'm going to select this here because this is what overwrote the instruction pointer. So now I'll come back to Freya. I think I'm going to have to open a new, whoops. Come back here to, let's open Freya again. And now we're going to check the offset. So I'm going to run offset.py. I will put this in. And as you can see, was found at offset 268. So that means my buffer size before the return address is 268. Okay, so what else I'm looking at here as well is what happened during the crash. So if I come over here to EAX register, you can see it's pointing towards 690 at the crash. So 690 would be right up here at the of the top of the stack. So let's hit and let's see display again. It won't. Okay. So this is pointing towards the top of my stack right here. So now what I can do like I could just write this in little Indian form and put it on a return address and jump to that. Or I could use a gadget here and say jump to EAX to the top of the stack. So what I'm going to do is I'm going to put a shellcode because we don't have DEP or ASLR turned on at this point. I'm going to put a shellcode below some knobs and pad it with some knobs on both sides. And then when the program crashes, I'll overwrite the return address with this jump ESP, and then it should jump to the top of the stack and execute our shell. It'll make more sense once I get into it here. So let's open up a new terminal here. And whoops, CD tooling, no. Okay, so I'm going to pop Freya back up again. And let's open our exploit here. So now I know my buffer needs to be 268. So what I'll do is I'll just start here by building out the exploit. 268. So now I need to put my shell code on here. And I also need to put a second buffer. So I'll call this one buff2. I also need to put a second buffer on the other side of that shell code. Now, my shell code, I know for a fact, is 23 bytes, but what I'll do, I'll just come over here to shellcode runner, and here is the shell code. And I made this one in a previous video, which I'll throw in the link in my YouTube after. But I've already covered making your own shellcode, which is a lot of fun as well. So that's where this shellcode came from. It's just a simple bin sh shell. I'm going to close this down too. Too many things open right now. So let's open up our exploit. Okay, so I forgot to save. So let's get rid of this. So let's put in x90 times 268. Shell is going to be right here. Let's put some quotes around that. Now, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So let's haul up our trusty calculator, and 268 minus 23 equals 245. So I'm going to say 235. And then I'm going to set a second buffer here with 10. Okay. And there we go. So now all we have left to do is we have to overwrite the return address with our jump ESP gadget. So buff2 and ret. So that'll be the layout of the exploit. So now we need to do two things. We need to find the base address of the libc library, and then we need to find our jump ESP. So what I can do is locate libc C dot shared object. And here it is. And I'm going to open Roper, which finds ROP gadgets for me. I'm going to make my own eventually, but it's harder than it's harder than I thought to program it. I spent a day on it, and this one just works so easy. So while this is loading up here, I'm going to open another terminal, and we'll go look for the we'll go look for the base address as this here is loading. We'll look for the base address of the libc. So I'm just going to put a break at main and run it. And then I'm going to hit VM map. And as you can see here, here is the base address for libc. Now, the reason we need this base address is because Roper gives us just the offset. So we need of the ROP gadgets. So we need to add that to the base address to get the actual address of the gadget. So let me now go to my Roper. Okay, so now we do search a depth of 1 for jump EAX. And here's our jump EAX gadget. And we'll post this here. So now what we can do is just haul out our programmer calculator and go to hex. So we need to add 29D02 plus B7E07000, B7E3, B7E3, 0D02. 0D02. So this is our address for the jump ESP exploit or gadget. So what's going to happen is we're going to fill up the buffer, first part of the buffer, with 235 NOPs, which means no operation. It's going to hit the shell code, which is 23 bytes. And then I put another buffer to fill up the rest of the buffer with some more NOPs. So what I'm going to put here over the return address is going to be, this is where we put in our jump EAX gadget. So little Indian convention, we put it in backwards. So 02, 0D, E3, and B7. And everything looks fine there. So I'm going to file, save that, and let's open up our Freya again. And I thought, and let me just turn this exploit into payload, and that seems to have worked perfectly. If it had any errors with my program, it'll pop up here. So everything looks fine. So now we can get back to the exploitation. So let's get back to our working files. And gdb/q vuln2. Okay, so I'm going to go right ahead and disassemble the vulnerable function. And here's our stir copy. I like putting it right before and just jumping into it myself. So there we go. Our breakpoint is set. Now we're going to run with our new payload. So cat payload that we made. And here we go. So I'm going to display 132 words X from the ESP. And here we go. Let me open up our window here and we'll print where is our EBP. set EE58, which is this one right here. This is our return address, arg1, arg2, and the stack pointer is up right here. So what I'm going to do, I'm going to hit next instruction, and this will be where we copied everything in. And as you can see, here's our NOP sled. Here's our NOPs. And then if you look at the shell, 31C0. So if we come back here, 31 is right here, C0. So this is the start of our shell code here. And our shell code runs right up to here, the CD 80, and then there's some more NOPs to fill in. And then here is our jump ESP gadget. So what we can do, we can check to make sure everything is copacetic there. So B7, E3, 0D02. That's what's overwriting our return address. So now what will happen, the program will crash, and when it returns to main, to libc main down here, it's going to see this address right here, and it's going to jump to the EAX. EAX is pointing towards the top of the stack here. It'll execute these knobs and hit our shellcode. So let's have a look, and let's hit continue, and boom, as you can see, process 8678 is executing new program bin dash. So that's how we pop a shell using ROP gadget jump EAX. And this is just a vanilla buffer overflow, but it's a good way to learn how to use these and how to chain these together. And I'll be covering a lot more of this in the coming weeks. I hope you enjoyed, and if you do, please share. And I will see you guys very soon. Bye, guys.